In Valencia, Spain, an innovative flight campaign is underway as part of the City Clim project. Valencia is one of several pilot cities participating in a series of overflights designed to gather vital climate data. This campaign combines ground and aerial systems to monitor urban heat and surface temperature with cutting-edge technology. At the heart of this campaign is the setup of a highly specialised base unit on the ground and an aircraft equipped with state-of-the-art sensors. Together they capture data that is crucial for understanding how Valencia, a city with dense urban areas and sprawling parks, is affected by heat.
Firstly, the sensor technology is unique. We don't use a standard broadband long-wave infrared instrument. Instead, we use one similar to those on satellites. This allows us to record long-wave infrared in 3 bands, enabling us not only to qualitatively identify hotspots, areas that are warmer than others, but also to assign actual temperatures to those ground locations.
The Overflight campaign focuses on gathering high-resolution thermal data using long-wave infrared sensors. This data helps determine the surface temperature distribution across Valencia, providing key insights into urban heat islands and climate stress.
The model already does this, but as with all models, it's just a representation. We need to see if this model accurately reflects reality. That's why we're flying over Valencia to gather real data about the actual conditions in the city, so we can compare the model data with the real data.
Alles klar, Herbert, wir haben Verbindung. Schau doch mal, ob du eine Freigabe kriegst. Wir können dann los.
Adrian Fessel is responsible for controlling the base unit and overseeing the data collection during the flight. Monitoring both the sensors and the incoming data in real time ensures that all systems are functioning properly throughout the flight.
These are the monitors where we can observe what's happening during the flight. For example, down here we have navigation information like the altitude of the plane and the speeds in different directions. We can also see what is currently being recorded by one of the onboard cameras. Since the sensors are central to what we do, we also have 2 monitors that constantly provide feedback about the sensors. They show temperature stabilization and how many images are actually coming in. This helps us determine if everything is running correctly, as these are experimental devices.
Korrekt läuft, weil es sich ja experimentelle Geräte handelt.
The mission's success depends on precise timing and coordination. Multiple overflights are planned over Valencia's different neighbourhoods, with the goal of capturing how temperatures fluctuate throughout the day and night.
We have 2 different objectives. One is to cover the city of Valencia as extensively as possible to verify the weather model. The second is to examine individual neighbourhoods and create a sort of stop-motion image over several time steps in a day, observing the neighbourhood as it heats up and then cools down in the evening.
The technology used in this campaign is highly specialised. The aircraft chosen for these missions is a motorised glider which minimises environmental impact while collecting high-resolution data from 3,000 metres above the city.
So we fly with motor assistance, but it remains a glider. This means the resource expenditure is quite low, the fuel consumption is low, and the emissions we release, such as noise, are minimised, so the residents in the city are not disturbed by our flights.
Throughout the flight campaign, data from the sensors is processed to create detailed thermal maps of Valencia. These maps provide a clearer picture of how different areas of the city, parks, residential areas and industrial zones are affected by heat at different times of the day.
After the flight, we primarily want to collect scientifically usable data, not just data for visual impressions. This means we need to apply calibrations that were done beforehand. We need to correct image errors. For example, some pixels might be defective. That needs to be corrected. And then it's important. So images are one thing. Ultimately, we want to get geodata. For that, we need to consider the navigation of the aircraft and the orientation of the aircraft's camera to project it onto the map.
The Overflight campaign is part of a larger effort by City Clim to create actionable data for cities across Europe. This data not only validates the weather models used in the project, but also helps cities like Valencia better prepare for the challenges of climate change.
In the CityClim project, we aim to fly at an altitude of 3 kilometres to achieve the required ground resolution of a few metres. At this height, a drone is no longer feasible. We need an airplane for that.
With overflights like these, Valencia and other CityClim partner cities are gaining a better understanding of how to mitigate the effects of climate change, one flight at a time.